is back again. We're on to our second section in the chapter 12. We're going to talk about electrical energy today. So it's kind of where does all of our energy come from? That's our big thing that we're going to be talking about. Without much further ado, back we go. Here's your homework for tonight. We're going to talk about electrical energy. Energy is really transported by the flow of electrons. So it's almost like thinking about the electron carrying energy in a backpack. If it's here, if it's the Roadrunner, they're transporting the energy from one place to another. That's kind of the easiest analogy, easiest way to think about what's happening with the energy. We measure how much energy they're carrying in joules. Joules is kind of the unit for energy that we're going to be talking about. So here it is. The electron is carrying the energy from one part of the circuit to the other. And then, of course, it gets used up by the electrical loads. Most of our electrical energy, as we probably know, just looking around the house, we have tons of things that use batteries, from remote controls to our iPods to our cameras. Anything like that uses batteries in everyday life. And then everything else tends to be hooked up to wall outlets, which, of course, comes from generating stations. We're talking about these big hydroelectric generating stations or coal-burning electrical and generating stations. But what they're doing is we are creating that electricity, taking it along wires until it comes to our homes, and then we can use that energy for the devices that need to use them. We're going to talk about these batteries. Now, there's two things we need to talk about. If it's just an individual battery, as shown here, we call it a cell. Technically, in science, it doesn't become a battery until we have two cells connected together, and then we can refer to it as a battery. But let's kind of go on what's happening here. These cells, they take chemical energy and they convert it into electrical energy. As I said before, you need two or more cells to be considered a battery. Inside this picture, you can see that there's a bunch of chemicals in there. A chemical reaction occurs, and that starts to get the flow of electrons going, usually from the negative to the positive terminals as they go, or from our negative, which is our anode, to our cathode. Remember, our anions were negative and our cations were positive, so it's kind of a little bit of a flip on those as we talk about the different words. Now, as we go to this, we can talk about two different types of cells that we can have. One is primary and the other is secondary. Our primary cells, they are one-hit wonders. These are the things that power most of our devices out there, even though we're starting to get more into secondary cells as we go. The chemical reactions occur, but the flow of energy only occurs in one direction, and these chemical reactions are not able to be reversed. So when all of the chemicals are used up, we are finished using these cells altogether. And both of these type of cells are hazardous to the environment, but definitely this one is. So we don't throw these into landfills. We have to dispose of them properly and get them to the places that can dispose of them so nobody gets injured at all. Our other ones are our secondary cells. This is where we can regenerate the chemical reaction so that we can reverse the chemical reaction to a certain extent, and they keep reversing and reversing. As we know, even rechargeable batteries have the chance to be able to die at the end of the point. So it's not infinite with this. But again, these also are hazardous to the environment. Perfect example is the secondary cells we have in our cars. We actually use our cars to reverse these chemical processes so we can use the batteries when the car isn't actually running, so we can actually get our car started. Now, they've got some new things called fuel cell vehicles, and these things are constantly reversing themselves, and they're constantly reversing the chemical reaction, and they're pretty cool. Essentially what they're doing is they're converting hydrogen and oxygen into water and then releasing energy, and then the car is using that energy. The only problem is, where do we get all this hydrogen from? Exactly, they come from fossil fuels. So we're getting to that same problem that we had before, is we're worried about hurting the environment because of burning fossil fuels. So we go to these special vehicles that they themselves are not burning fossil fuels, but in order to get the products they need to work, we have to burn fossil fuels. So we're kind of in a little bit of a catch-22 situation there. So are we helping? Are we harming? Same thing with the ethanol. We talked about the ethanol, where we take so much fossil fuel energy to actually get these ethanol crops processed. Is it more than what we're saving by adding them into our gasoline? Anyway, back to your homework. Hope this podcast does you well.